My dear students, a very warm welcome to you. In this video, I am going to discuss mathematical symbols and their definitions. As you know, mathematical symbols are widely used in some social sciences that includes economics and statistics. They may also be used in some other social sciences, but economists use a huge use of mathematical symbols and their definitions to explain various theories and functions. So in order to explain that, let me start with the introduction. In order to study economic theories, we require to understand mathematical symbols. As I mentioned, these symbols are used as shorthand to describe the theoretical concepts in economic theories and research studies. As such, economists need to have some quantitative skills. The more comfortable they are with mathematics and econometrics, the better of their research and career opportunities. But economists are not mathematicians. So, when students of economics take bachelor's or master's course while studying their economics degree, they might be presented with the symbol heavy lecture notes. So, most of the modern economists use a lot of mathematical symbols in their lecture, especially in microeconomics and macroeconomics, etc. Without the understandings of these symbols, uh, economic students will probably struggle to read them, leaving their meaning unclear. This lecture will discuss what are the most commonly used mathematical symbols in economics and what do they mean and what do they stand for. Let me start with some mathematical symbols. This symbol means plus or minus. Uh, it is most often used when describing an interval of some sort, such as confidence interval. So, plus minus includes both plus or minus. This symbol less than or equal to and others like it are used often in economics to describe preference relations. And this relation means at least this means less than or equal to. Preferences are the basic building blocks of the demand theory. This symbol is seldom used outside of microeconomic courses that specifically focus on preferences. This symbol means that the variable on the left side is proportional to the variable on the right hand side. If you see this symbol, this means similar to, whereas this symbol means approximately equal, which means something is almost but not quite equal to something else. So it means approximately equal to. These two lines, that is parallel. In economics, this is used most often in econometrics when describing how things relate to each other geometrically. So this means parallel. This symbol is perpendicular or orthogonal. Perpendicular means two things intersect at a 90-degree angle in geometry. In econometrics, orthogonal means that one variable has zero power to explain another variable because because they have a covariance equal to zero. This mathematical symbol means is contained or it is used for in, so that a variable on the left hand side is contained within a variable group or concept on the right side. It can be reversed to mean the opposite. For example, often in economics, a theory will describe which value of x are possible. If x can take on all real number values, the description might start with x belongs to R or x is contained in R, where R is the real number set. This means that x can only be a real number because it is in the set of real numbers capital R. This symbol is used to describe the Kronecker product, which is a matrix algebra concept which comes up occasionally in econometrics. This symbol means partial. It is also known as curly, and it is used to denote partial derivative. So this is used in partial derivative. This capital I with subscript n is used to denote identity matrix with n dimension, that is n rows and n columns. It is used frequently in statistics and econometrics. This symbol dot, when placed above the variable, signifies the derivative with respect to time of that variable. So this symbol is commonly used in macroeconomics, but seldom outside of that context. Uh, Greek letters are widely used in mathematical language, and these are often used to denote variables, but some carry special meaning because of how often they have been used in certain contexts. For example, alpha. Alpha is the first Greek alphabet, and when used in Douglas production function, it denotes exponent. Also used when discussing p-values in hypothesis testing, the alpha level sets the number that you compare the hypothesis test result to. This basically means predetermined significance value. Then we have beta. Beta is also the second alphabet in Greek letters, and this is also used as an exponent in Cobb-Douglas function, Cobb-Douglas production function, or any other function. But it's most famously used when describing regression formula. It is used as a partial regression coefficient. The letter epsilon is commonly used in regression analysis, and this basically denotes the error term or the stochastic disturbance term. Many introductory econometrics classes and any other courses that showcase regression analysis will make frequent use of this symbol. The letter delta is used often to denote the change in a variable or depreciation in macro. For example, in the study of national income accounting, this may be used as depreciation in capital or capital consumption allowance. Lambda is another Greek letter, and this is used often when solving constraint maximization problem using the Lagrangian method, and sometimes it is called as a Lagrangian multiplier. The letter mu is widely used in statistics, which denotes the population mean or average of something. The letter rho is often used in statistics to denote correlation coefficient between two variables. Similarly, sigma, the capital letter sigma is used frequently to denote the summation or the sum of various things. The lowercase sigma is used in regression analysis and statistics to denote the population standard deviation, but when squared, it is known as the variance, population variance. The capital letter phi, when used, it denotes a probability distribution in statistics, most commonly the cumulative distribution function of the normal distribution. The lowercase phi is often used to denote the probability distribution function of the normal distribution in statistics, but this is frequently used outside of this context, unlike the capital version described above. This letter, Greek letter chi, used in statistics to denote the chi-square distribution, but when it is squared, then it means chi-square test, which studies the association between two qualitative or descriptive variables. The capital letter omega is used in econometrics to be the symbol for a matrix. There are some other Greek letters which usually don't carry special meaning on their own, but are often used in economics anyway. They are commonly used as placeholders for variable when discussing theory or equation. This is letter gamma, this is eta, this is kappa, this is nu, this is tau, this is epsilon, this is the capital letter psi, this is the lowercase letter psi, this is the lowercase omega. So these are the various Greek letters that are used in mathematics, also used in statistics, econometrics, and in economic theory. Ladies and gentlemen, thank you very much for watching this video. If you haven't yet subscribed to the channel, kindly do subscribe, and don't forget to click on the bell icon so that you can get timely notifications about my other videos that I'll upload for you.